Again, we welcome you all. Our dream at the Syracuse Center of Excellence is that we create intellectual collisions. So our idea of what will happen this afternoon is we're going to hear some ideas from some presenters on opportunities relating to a natural resource in the region. And we're going to have a conversation about what the opportunities are for the region. This is can be put in the context of broader opportunities in the region for creating jobs and creating new industries relating to energy and environment. Pleased to recognize Councilman Bay from the city of Syracuse. Councilman, if you'd like to share a few words about, he came recently and talked about his vision for, a vision that he has about tapping the resources of people and ideas in the region. Councilman?
Appreciate it. I will be brief. I took the time and the opportunity to invite some of my overlapping electeds or maybe their representatives, as mentioned, from the Faye's office, Gillibrand's office, County Legislator Monica Williams, Linda Irving, Scott Butler, and Craig Wilson from Senator Valesky's office. Obviously, because the idea, and many ideas, obviously even ideas you're working on now, certainly require public-private partnerships and support from all levels of government. But what I spoke with Ed and a few others about was an idea of creating new industry. I always joke about the fact that Syracuse has nothing signature except snow and SU basketball. So, an idea of new industry centered around a resource that we get, or that we receive pretty readily, and also to expand on some of the great work being done by the county executive in the county with Save the Rain, and some of the other water projects like the work that Honeywell is doing out at the lake. But what I'm talking about particularly here is building new industry around water use and water treatment. And while we are doing some, what I would call spot innovation, this would be a purposeful intent to create ideas and to generate industry around that kind of work. Along with this idea, we would retain and of course attract, in my opinion, of course Ed knows that, you guys are the experts, so this is idea, you guys put it in motion, but attract and retain inventors, experts who would literally purposefully come up with ideas for water uses, come up with ideas for water treatment, and then for the engineers and the designers of the like, design whatever, for, and excuse the term, apparatus or whatever is required to do the work. Best case scenario, we would not only invent it, create it, and develop it here, we would manufacture it here, we would sell the parts that's required for manufacturing. But the whole idea is centered around building new industry. I thought I had something new, and then Ed showed me that there's a remnant of this idea happening in Minneapolis already. So I can't be too crazy to come up with it. But again, one of the greatest ideas relative to this is doing our best to buy as much as we can local to try to regenerate the industry. Of course, I would love for it to stay in my council district. I brought all of my overlapping to try to get their support in that respect. But I think we have a great opportunity here. I think in the last few weeks we've seen a lot of money fall out of the sky. And I say money because I'm referring to raindrops and snowflakes as currency. You add to this idea, and I'm cutting it short, Ed. To this idea, I had this idea when I first got elected on the council, when a lot of my colleagues kind of laughed at me. These guys didn't, of course, because they think farther than I do in this kind of idea. But we also talked about snow treatment. We have a serious snow removal problem here. And it's not unlikely the idea of creating maybe some component for maybe melting, treating snow, converting it into steam. One example of how this kind of energy could be used is to work to take municipal buildings off the grid, create power for them. And of course, if you're an expert, you can correct what I'm saying or maybe improve upon what I'm saying. But I'm just sort of throwing the ideas out there and want to reiterate purposeful intent to generate industry. I think we have an opportunity here to maybe take another leap in our efforts to lead the nation, maybe even the world in innovation, innovation of this type. You know, and let me add one more thing to the snow removal, and that's what I'll get out the way. I told Adam I think we will make a killing, you know, receiving other people's snow who have problems with snow. You know, so they essentially pay us or our companies here or the private person who's picking up and dumping snow into whatever this contraption is one of you will invent, you know, to melt the snow, and we charge a fee for getting rid of this snow. And, you know, even if we can figure out a way, you know, to transport all that snow they have up there in Watertown, you know, obviously the amount of energy used to transport it has to be less than what it produces, but if we can even figure that out, you know, keep in mind we have to patent this. We don't need anybody sort of taking our ideas, but, you know, I think we have a lot of opportunities similar to scrapping, where even private small businesses could, you know, have opportunity for snow removal, you know, and make profit thereby. So I just wanted to sort of put it out there. I wanted the representatives from the various levels of government to maybe hear it, take back to the senators, the assemblymen, and the like, and to lend support to the effort if and when you guys sort of hit the accelerator. Because I think it's something that should happen. I think we can literally resurrect this city, Central New York, even though we're doing a good job so far. I think it's right up the alley of what you're doing already. We might as well improve on it and focus in this kind of way to have this, what I believe would be a great success for Central New York and the state of New York in general. Ed, thank you for your time. Appreciate it.
Thanks very much. We appreciate your vision, and we welcome everyone here. You came for the main event, so let's get on. I'm pleased to introduce Doug Call, a new faculty member at Syracuse University in the Department of Civil and Environmental Engineering. Doug received his PhD in environmental engineering in 2011 from some school in that little school in Pennsylvania State, Penn State.
That's
where Doug researched microbial fuel cell technologies for converting wastewater to energy. And when Doug looked around the country for where he wanted to be on the faculty, he really could have gone anywhere. And he came to Syracuse. And we're thrilled to have him. So Doug, after his PhD, continued as a postdoc at Penn State. Doug's research interests focus on biological processes and environmental technologies that will lead to a paradigm shift in the way we treat water. Doug Call.
great. Thanks, Ed. Before we get started, I want to especially thank the COE for putting this event together. In particular, all the people that work behind the scenes to make this event happen and to continue to make these forums happen. I also want to recognize Tim Lebrecht because he did a lot of work coordinating all the speakers and working with me to get the speakers here today. So what we want to talk about today, and what I want for all of you to be thinking about when these speakers come up and talk before us, is thinking about the potentially unconventional source of energy that's below our feet right now, and that's the brine aquifer. We want to think about how can this aquifer provide opportunities, not just in terms of economics, but for energy for the city of Syracuse. We want to think about how we can bring industry and academics together in order to figure out what are the pressing questions and the technical challenges that we have to overcome to get the technologies that we're going to talk about today into practice. And also think about what are the collaborations that we need to start building within the community to move these ideas forward. So to do that, what we're going to do is we're going to start with figuring out what is below our feet. And Bill Kappel from the USGS is going to help us out with that. He's going to talk about the characteristics of the brine aquifer. How big is it? How salty is it? If we started to use this as a resource, what are some potential environmental impacts that we need to be thinking about? And then we're going to jump into a first demonstration of a technology that's currently being used to harness energy from the aquifer, and that's geothermal technology. So we're fortunate to have Mike Madigan from Brine Aquifer to talk about that. To give us an overview of how do these systems work, how are they designed, what are the technical challenges, and what are the advantages and disadvantages of using a brine aquifer in a geological system. To add to that, Sam Cosimano from IPD Engineering is going to talk about a real-life project that's occurring right now downtown involved with the Pike Block project, where they're actually installing a geothermal system. So he's going to tell us a real-life example of how this technology works and some of the challenges they've run into. And to wrap the whole thing up, we're going to introduce a totally new suite of technologies that are just starting to be commercially realized. And that's why we have Dr. Young Kim here today from McMaster University in Canada. He specializes in membrane-based processes for harnessing electricity from the difference between saltwater and freshwater. This is an emerging technology, but it has a lot of potential. We've already seen in places such as Norway, they're building pilot-scale demonstration facilities. So we want to be thinking, is this a technology or a group of technologies that we could establish here in Syracuse? How would we do it? And what are the main challenges that we face preventing us from doing this? So, in order to get started, Bill Kappel is going to introduce us to the brine aquifer. Bill Kappel is a hydrogeologist, emeritus, he pointed out to me, for the U.S. Geological Survey. He received an undergraduate degree in physical sciences and dual graduate degrees in civil and forestry hydrology from, what was that small school?
We are.
Penn State, okay. Penn State.
Another line.
He's worked for the USGS New York Water Science Center in Ithaca, New York since 1979. So we're very fortunate to have him here. Prior to that time, he served as hydrologist for the U.S. Forest Service in Missouri and Wisconsin. Past investigations in this area include the Onondaga Trough, where he studied the movement of natural brine to Onondaga Lake, the study of mud boil activity in the Onondaga Creek Valley, the study of landslides in upstate New York, and carbonate aquifer studies in western New York. He's also coordinated USGS water resource information and study efforts related to shale gas development in New York and with other water science centers across the Marcellus Shale region. Bill, thank you.
I want to save that. First of all, I'm a geologist. I'm along with the beard and no tie. Okay, today what I'm going to be talking about is the Onondaga Valley and the brine-filled aquifer. Out in the hallway, I have two USGS fact sheets, one on the Salt City, and then another one on the hydrogeology of the Onondaga Trough. And there's even some salt information in the back of that one, so they're available outside. And just to give you an idea, the brine in the aquifer, one of the things we'll be talking about is the use of the brine for de-icing of the city and county roads in the area. For every half gallon of brine, you get this much salt that's in the aquifer. I'm going to pass this around. You can play with it. But this is how much salt is in a half gallon of brine that's in this aquifer. There's a tremendous amount of salt. Okay, I'm starting out with this slide. I have a warp sense of humor. Basically, if it wasn't for the glaciers, we wouldn't be here today talking, because the glaciers is what created this aquifer system. Okay, if you go back to the early, or actually the late 1700s, this is the southern end of Onondaga Lake, also called Salt Lake. And these were the locations mapped out by one of the early explorers of salt springs in this area. A little bit closer to home, again, what is now Lake Creek. This is Harbor Brook. That's where Onondaga Creek is now. And here is Onondaga Creek where Kappel is, or excuse me, Destin. All these red dots are salt springs. To give you an idea, Kirkpatrick Street here and Spencer Street, roughly where they're located. Syracuse has a tremendous history of salt from natural and man-made situations. The Salt City in 1898. This is a map of downtown area. These locations here are the salt sheds, where they got the brine out of the aquifer here, and on the days when it was sunny in Syracuse, they were evaporating away the water, to make salt, much like is being passed around right now. And tremendous amounts of the area, Carousel Mall area, Lake Creek, up toward Liverpool, even at the, what is now the Honeywell plant site, there were these salt areas where they were taking out brine, evaporating away, and making the salt for food preservation. This is before carrier. The salt that was produced, roughly for 125 years, would fill the carrier dome about 3.5 tons. Okay, there are historic reports in downtown Syracuse of wells being used and water being pumped out of the ground to cool dairy processing, for beer making, and things like that. Many of those wells probably discharged to either storm sewers or back into the creek and into the lake. Also, the Niagara Mohawk building, back in the 1960s, they were using geothermal. They drilled wells down about 60, 80 feet, got into a very coarse gravel. That water came up, they used it to air condition their building, and they discharged it to Onondaga Creek. And this went on until the early 1990s when this was discovered. And it turns out that they discharged about 25% of the load of salt that got into Onondaga Lake. They were shut down. So, brine has its beginnings and its endings. Okay, this is the salt industry. It's not the pump house. They're not taking it from the rock. They're taking it from the unconsolidated aquifer. This is in the Liverpool area, and you're looking over to where solvay processed outlet is today. Another place where they got salt, this is the second phase of the salt history, was in the southern end of the Tully Valley. A couple of gentlemen went over to Solvay Brussels and got what was called the solvay process, brought it over here, and using brine, limestone, and ammonia, made soda ash. Soda ash in the late 1800s, early 1900s was the plastics of the day. It was used in everything. If you made soda ash, you could get rich real quick. By the way, there was never salt under Syracuse. The salt beds basically ended down by Route 20, the southern end of the Onondaga Nation, Lafayette Apple Festival area. There never was salt beds under Syracuse. So, when the solvay process came in, they were hoping to use the brine from the southern end of this area, but all these industries here had taken most of it out of the ground. So they sent some geologists out, and geologists being geologists, we drilled wells, and finally in the southern end of the valley, they developed what looked like oil wells, which by the way, Drake was drilling for salt when he hit the oil. These are the same process here. This is called cable tools. Okay, this is a cross-section of the Onondaga Valley from Onondaga Lake down to the Tully area where the brine fields are located. The edge of the inland sea is located here. So again, there never was salt under Syracuse. So how did it get to be called the Salt City? By the way, we are here. We have this aquifer that was created by the glaciers. Glaciers came through, carved out this bedrock valley, and as the ice went back out, it laid down all these deposits. By the way, the glaciers didn't do this at one time. Over the last 2 million years, there have been 4 major episodes where the ice would come in, wipe out the material, erode the bedrock, and as it receded, would lay these layers down. This is what we have today. This area here is the Lacustrian silts and clays, not permeable. The orange colored is a fairly coarse sand and gravel. There's also a sand and gravel layer along the bottom of the valley here. In the Syracuse area here, we have a lot of sand and gravel that came out of the West Branch Valley of Onondaga. And in this area here, this is somewhat coarse-grained material. Underneath the lake, we have fine-grained material. The salt beds terminated here. We think what happened as the ice eroded down, it finally intersected the salt beds. And what was happening underneath the ice was that it was very cold. The salt was ground up by the ice, but because it was so cold, it became like a slushy, and it just sort of held there. Once the glacier moved out and laid these materials on top, the heat of the earth came in, melted the slushy, and since brine is denser than fresh water, it flowed to the lowest part of the valley. So this part of the valley is basically impregnated with brine. This is a picture just showing, in this case, sodium, and what we see here is from West Seneca Turnpike or Seneca Turnpike to the south. We really don't know what we have in this area here. We know in the Tully Valley we have water that is about as salty as seawater. In this part of the valley is where we have the brine resource. The most concentrated is about 60 to 80 parts per million. Sodium chloride is even higher. Why it's not down here, this is the area where all those brine wells, where they developed the salt and turned it evaporated. This is a finer grain sediment in here, but this is the brine resource, basically from West Seneca Turnpike, underneath the lake, and actually further north from the lake. This is the Meacham borehole. It's about 420 feet deep. Different types of stratigraphy, sand and gravel at the surface, very fine sands and silt, not very good for pumping water, another coarse grain layer. And most of this down in here is pretty fine grain material. These are the salt concentrations right here. This is in chloride, in grams per liter. This is seawater quality right here. So you have to go down about 150 feet to find seawater quality. But as you get deeper, we get 2, 3, 4 times as salty as seawater brine down in here. But you can't really pump it because it's very impermeable material. Spencer Street, if you know where the City Parks Department is located. Again, 20 milligrams per liter. You only have to go down seawater quality down about 40 feet. It increases even more until you get 6 to 7 times as salty as seawater, and that's what you have in the aquifer. That's about as salty as you get. It's about 80% saturated. Again, up in here, coarse material, so you can pump water here and use the brine for whatever purpose you want to. Down in here, it's very fine sand. You can't pump much down here. There is some coarser sand in here, but for the most part, not all of this aquifer is conducive to basically remove brine. All right, this is a geologic section, basically from I-690 from Hiawatha Boulevard to Route 81, basically right through this area. The Onondaga Valley is here, where we are located right here. There's not much from the glacial sediments to get the bedrock. So if you're going to be looking to produce brine for whatever purpose, you've got to be in the valley. Down here we have some fairly coarse deposits, again fine grain deposits, and coarse again up near the surface. Another geologic section, basically across Hiawatha Boulevard from Porter Street School area over to Park Street. We're in the main part of the valley. Fairly coarse material here, fairly fine grain material here, moderate grain material here. The only thing consistent about the glacial geology is its inconsistency. So when you drill in a location, you don't know what you're going to find every time. Okay, so where's the brine-filled aquifer? That's what you came for. Okay, this is the valley walls here. This pinkish sort of color here, this is the deeper part of the aquifer system. This is West Seneca Turnpike, where we had one sample. Up here at Spencer Street is another. This is the 9-well well here. This well was only 60 to 80 feet deep. And they had very, very coarse gravel. We have the Spencer Street well. We borrowed a couple of the wells when Destiny Now was looking to expand. We looked at their area and we found a lot of brine there. Also, right in here is the New York State DOT. We helped drill a well for the state DOT where they are taking brine from the aquifer, transporting it over to Fayetteville, where they're concentrating the brine to get it up so that they can use it for basically de-icing and anti-icing in Syracuse, in Fayetteville, and in surrounding communities. The salt we get out, or the brine we get out of the aquifer, is about 45 to 50% saturated. They need about 82% saturated for brine de-icing. So they just add a little bit more salt in Fayetteville, and it's used around here. This is the well that was drilled for the Department of Transportation fill real fine material. This zone right in here is where they get their brine. It's about 140 to about 160 feet down. They can pump about 40 to 50 gallons per minute, and it's about 50% saturated. I stole the slide from Sam. Basically, the open loop that he's going to talk about is a system where they pump the brine out, go through a heat exchanger, and the brine goes back into the aquifer. There is a transfer system in here that's separated from the brine system, and that's what they use for heating and cooling. So I'll explain that more.
I can go home now.
No, you got more to talk about. Okay, what are the obstacles of using this aquifer? Number one, the permeability is inconsistent. You can't use it everywhere. The location is west of downtown, so you're going to have to transport it if you want to use it over here. Or, like they did here, they drove in the bedrock. The corrosiveness of the brine. This is not Perrier. This is extremely corrosive. In fact, at NIMO, they were pumping brine. They didn't know it because they were dumping it in Onondaga Creek. All their equipment was corroding over time. They didn't know it. They didn't know they were pumping brine. Use of brine for re-injection back to the aquifer. Are there regulatory hurdles? Sam and company basically found out the DEC was fine with taking it out and putting it back into the same system. But if they took it out and dumped it into the storm sewer, they wouldn't have been allowed to do it. You gotta put it back from where you found it. And then finally, a train contamination from elsewhere. We have contaminant sites. This site was built on a contaminant site. There was a coal gasification plant at NIMO, and for years they've been removing that contamination. Of course, they were doing it by pumping the brine. But basically, you have to be very careful. If you drill a well here and have a cone of infiltration, you may be pulling gas, TCE. You have to understand that. So both DOE and for the pipe block, they looked at the water quality. Okay, questions? I was told to hold to the end, but I do have my show and tell. I'm going to talk about the Spence Patrick Brine Spring. There is a brine spring in Onondaga Creek between Spencer Street and Fitzpatrick Street. That's where it got its name. And so what we did was we had a diver go in, and this is a picture of Onondaga Creek. This is the Spencer Street Bridge. Go ahead, start running. He's going to do a Mike Nelson sea hunt. He's going to go down. This is slightly turbid water in Onondaga Creek. Now pretty soon you're going to see like an oil-water interface. Soon. That's brine. That's the brine that you can basically evaporate away. This is a pool that sits in the creek. Steve Effler, many years ago, was doing surveys and he said there's a source of salt somewhere in here. So during a very dry period, it came in with a conductivity meter, looked like a blind man going up Onondaga Creek, and I was looking at my meter, and I started picking up the brine, and this is what I found. It's a hole between Spencer and Kirkpatrick Street. It discharges about 500 gallons a minute of brine.
500 gallons
a minute. Realize, Syracuse is known as a salt city. It's the salt city because there were salt springs around the lake that they utilized to make the brine, to make the salt. There's also air and carbon dioxide that comes out. Again, we're in the brine. It's not moving. It's dead still. Everything is very well preserved. I have lots of stories I can tell you. So we can cut it here.
Why is it moving if it's 500 gallons?
Basically, it's coming up through there, so it's fairly still, and then it's being pulled off by the creek.
It's heavy. It's like a heavy.
It's denser than fresh water. And this just shows you that if you disturb the bottom, you'll get these air bubbles. So there's air and carbon dioxide coming out of the ground along with the brine. That's all.